Yes, hi guys. Today I'm taking next topic, next subject. I mean, matrix algebra or matrices. Okay. Now, in this case, what are the matrices I'll talk about? Types of matrices are taken today, and definition. What is a matrix, and what is the use of matrix for the management students or management people or managers? Right. That I'll talk about. First of all, what is the then application of matrices in different fields. This is for management I'm taking, okay, because some of these questions have taken from the student side, okay, from the managers, mostly management students, MBA and BBA students. Okay, so this subject is found in mathematical techniques or okay, yes, management techniques or mathematical techniques. Okay, so MQ or TQ, technical, okay, methods or technical, yes, um, methods, yeah, technical methods or mathematical, analytical, sorry, analytical mathematics or mathematics in case of management students. So let me take now this is one of the topics which is very important in case of management students. Let me take that what is the importance of matrix algebra for management students. First of all, in case of management, okay, or technical analysis, okay, in case of matrix algebra is useful to find the techniques with the help of simultaneous equations, solution of simultaneous equations. Because with the help of matrix, we can solve simultaneous equations. Then different kinds of okay techniques can be calculated. So what kind of techniques are there? These are the important for technical analysis in case of management students. Okay, and now application of matrix algebra is for higher mathematics, mostly found in very useful in or great use of mathematics of this matrix algebra in case of higher mathematics, in case of aerodynamics, mechanics, okay, nuclear physics, all right, and then algebra, differential equations, okay, etc. So almost all the higher mathematical subjects they include this matrix algebra because in that situation, different kind of situations arise when we have to use the solutions of simultaneous equations, okay, and different techniques are to be calculated, okay, by assembling of different kind of situations. That is how the position is there. Now let me define that what is a matrix or what is a matrix. Matrices. Types of matrix means matrices. Matrices is a plural number, and matrix is singular. So types of matrices. Then I'll talk about these types. I've taken today. I've taken only briefly 13 because 1, 2, 3, 3 last, and 10 I also 13 types of matrices I've taken. Still there are a number of matrices types which I'll take in the next lecture series, okay, in which I'll take nilpotent matrix, how to find transpose of a matrix, how to find inverse of a matrix, okay, then importance of what is the application of transpose of a matrix, then uh, addition, multiplication of matrices, etc. I'll take in the next lecture series. But before that, I'll just introduce what is the matrix algebra and matrix. Let me define what is a matrix. So definition I'm talking about. Definition of matrix. Okay, an arrangement of mn numbers. What is m into n or mn numbers? Mn numbers in rectangular array form. In rectangular array form or in m rows and n columns. That is the idea. Mn numbers in rectangular array form in m rows. This is m here. M means mn means m rows and n columns. Mn numbers here may be real or imaginary, doesn't matter. Numbers can be real or non-real or imaginary. Mn numbers are, the numbers may be real numbers or non-real numbers or imaginary numbers. So these numbers when arranged in rectangular array form in m rows and n columns, okay, is known as a matrix. An arrangement of numbers, mn numbers in the form of m rows and n columns is known as matrix. Is known as matrix. Is known as matrix. Okay, so is known as matrix. Now it is represented. It is represented by capital letters, like in either A is equal to, this is Aij of order m by n, read as order m by n of order m by n. This is m by n order. A is equal to Aij. Capital letters represents a matrix, and Aij, small letters, represent elements. Where A is the representation for matrix, is the representation for the matrix, and Aij represents its element in ith row and jth column. And how it is represented? So it is represented symbolically. Let me write here. It is represented symbolically as, let me write here, A is equal to, if I take A11, A12, let me take A13, A1J, let me take, this is jth column, okay, and A1, this is A1 here, let me take n here, nth column, then A21, A22, A23, A2J, and this is A2N. Then let me take, okay, in summarized form, this is this is A12, not A21. Yeah, this is A21, A22, that's it. This is A, let me take M1, mth row, AM2, and this is AM3. What I'm writing here, this is AM3 here, and after that 3 dots, AMJ, 3 dots, this is 3 dots here, and AMN, mth row and nth column. This is nth column. Here the columns here, and here the row. Horizontal are the rows, and vertical are columns. So this is second column, third column, second subscript denotes here. First subscript denotes number of row, in which row the element is lying. The first subscript I represent the number of row. Second subscript J represent number of columns. So the element here is lying in ith row and jth column. That means Aij represents symbolically. This is in general. Okay, so this is in general we have represented A equal to Aij, or simply just write Aij. Order is not written sometimes, but just we write Aij. Okay, or Aij of order m by n if order is given to us. So here it is. So first subscript represent, let me write that what is I and jth row represent. So first subscript in, let me write here, in A is equal to Aij, where of order m by n. This is of order m by n. Here in Aij, the first subscript I represents the number of row, and second subscript represents the number of column. Okay, so number of rows and number of columns. So first subscript I represent number of row, in which row that element is lying. Okay, so let me take some numerical examples here of rows and columns, so that we can understand that what is this is rectangular array of numbers represented as in the, or it is represented in brackets form. Okay, so a matrix is represented in the bracket form, right? Represented the matrix or matrices are represented by capital letters. Undoubtedly we have written down that capital letters in brackets. So in brackets, in brackets we have to move down this. Like, let me take A is a matrix 2, 3, 4. Let me take 1, 2, 5. This is of order 2 rows and 3 columns. It is 2 by 3, of order 2 by 3 here. So this is 2 rows. This row, first row, second row, 3 columns, first column, second column, third column, 2 by 3. Second subscript represent number of columns. First subscript represent number of rows. So 2 rows are here and 3 columns. So this is representation numerically. Okay, like B is equal to Bij. If I represent another matrix B by Bij, let me take here order again m by n. Okay, or here B can be 1, 2, 3, 4, 6, 5. Let me take. Now this is a matrix of order 3 by 2. Why? Because 3 rows and 2 columns, 3 by 2. So this is a matrix representation. Okay, now matrix representation we have done. What is the matrix definition and how the subscript represent number of rows and number of columns, and capital letters are used to represent the matrices, and small letters represents elements. Elements are found in the bracket side. I mean, they are the elements are the part of the matrix. Elements represents, for example, A11, A12, A13, etc. are the elements here. Okay, so now let me take the definition of matrices. Some types of matrices, I mean. So definition part are completed. Now let me take types of matrices. First type of matrix is a row matrix. Now these are taken from students' query, there are number of other matrices, about 32, 35, 36 types of matrices are there. I have taken at the moment 13 types of matrices. I'll take in case of transpose of a matrix, okay, then inverse of a matrix, adjoint of a matrix, nilpotent matrix, what is the skew Hermitian matrix, etc. Then okay, nilpotent matrix, idempotent matrix, etc. So these I'll take in the next lecture series, which are some of bit difficulty. Okay, so our difficult level is higher of that. That I'll take in the second lecture series. First I've taken the easier one, the beginning one of the in the beginning. So beginning types of matrices, or in the beginning we take this easier one matrices are taken here. Okay, so because number of types of matrices are given or asked by the students, that are taken are noted down then, but those are taken in the second series. If any one left, then please remind me so that I can take that or explain that in the next lecture series. Okay, so let me take now the beginning one. I mean the starting types of matrices. First is the row matrix. What is the row matrix? Let me define what is the row matrix here. Okay, so row matrix. If a matrix has one row only, if a matrix has one row only, that is known as a row matrix. That is known as a row matrix. Means it is having only one row. Columns are not limited. I mean they make many. Okay, but at least two columns are there, but one row only. Okay, so if I represent a column matrix, let me take A here. Okay, so A is a column matrix. If it is taken, then A11, A12, A13, then A1J are taken, and A1N. So this is a column matrix to represent only one column. Okay, so only one column. First number, first subscript represent, this is 1J, 1N. Okay, N columns, and if I take numerical value, let me take B, it is 2, 3, 4. A column matrix of order 1 by 3. 3 columns are there, one row only, one row. Okay, let me take C, another matrix. It is 1, 0, minus 1. Okay, 4, 5. This is again row matrix of order 1 by 5 here. 1, 2, 3, 4, 5. 5 columns are there. So these are the row matrices. So a row matrix is represented by single row. If a matrix has only a single row or one row, columns are many, or columns may be more than one, that is known as a row matrix. So this is a row matrix here. Okay, it is represented like this. Aij, if I is equal to 1, j may be 1, 2 and so on. Where we can write A equal to Aij of order 1 by n, where I is equal to 1 only and j is equal to 1, 2, 3 and so on. Okay, so I is only 1. Aij represents the elements. This is a row matrix here, 1 by n, where I is equal to 1 and j is equal to 1, 2, 3 up to n. Okay, maybe up to n. Okay, so this is how a row matrix is represented by. Okay, so symbol for row matrix. Now let me talk about second type. What is the column matrix then? Okay, so in case of column matrix, if there is a single column, if a matrix has single column or one column only, second type is column matrix. What is a column matrix here? Let me talk about column matrix. Okay, so column matrix. If a matrix has one column only, that matrix is known as column matrix. That matrix is known as column matrix. Okay, for instance, if I write A is equal to Aij, where this is I to 1, I by 1, where, or let me take, this is m by n, where m is equal to 1 only, where m is equal to 1, n is equal to, sorry, not 1, but m is equal to 1, 2, 3 and so on. M is equal to here, sorry, this is to be represented as n, this is m by 1, where m is equal to 1, 2 and so on up to n. Okay, this is order m by 1, so one column only. Okay. Where yes, m is equal to, m can be 1, 2, 3 and so on, any number of, this number m may vary, m rows may be many, but column is only one. Okay, so this is represented by m by 1 too. Okay, m by 1, and there we could write 1 by n. Okay, the order was 1 by n in that situation. So in this case, let me write the elements here. If A is equal to 1, 2, 3, let me take 4. This is a column matrix here. This is of order 4 by 1, where m is equal to 4. M may be 4 here. Here m is equal to 4 and n is equal to 1. Column is, this is column matrix here. Only one column, not more than one column. Rows may be many. So rows are 4 here. This is of order 4 by 1. 4 rows and one column only. So this is column matrix. This is a column matrix. This is the column matrix here. Okay. So here m is equal to 4 and n is equal to 1 only. So column matrix in this way, or we could represent it as in general form. But this is A1, or let me take A11. This is A21, A2, A3, 1. Let me take. And generally, if I write, it is AI1 and so on. This is M1. The last element is AM1, right? I1, 3, 1, 2, 1, 1, 1. That means the number of rows are many, 1 to m, but column is only 1. This is column matrix of order m by 1. This is of order m by 1. Okay, so this is column matrix. Column matrix here. In this way, we can write it as column matrix. Column matrix is having only single column, one column, and rows are many. Okay. Column matrix. Let me talk about next. Square matrix. What is a square matrix? Okay. Third one is square matrix. Now, if I define a square matrix, then two matrices. If a matrix has, or I'll just talk about when two matrices are equal, that is equality. Now, square matrix is having same number of rows and columns. That means if a matrix has same number of rows and columns, what does it mean? Or in a matrix, if number of rows equal to number of columns, or in a matrix number of columns or rows, first number of rows is equal to number of columns, is equal to number of columns. That matrix, then it is, or that matrix is known as square matrix. That matrix is known as a square matrix. Okay, so in a square matrix, number of rows equal to number of columns, like Aij, or let me take A is equal to Aij, where number of rows equal to number of columns. If m is equal to n, or it is m by n, or Aij of order n by n, right? So m by n or n by n, we can say number of rows equal to number of columns, means they have the same number of rows and columns, same number of rows and columns. The square matrix. Simply, if numerically, if I represent, let me take B is equal to B is 2, 3, 4, 5, 2 by 2 matrix, square matrix. Okay. C, there is a matrix 2, 1, 3, 4, 3, 5, and this is 1, 2, 3. Okay, so it's a square matrix of order 3 by 3 here. Same number of rows and columns. So number of rows equal to number of columns here. This is a square matrix. So a square matrix is defined when number of rows equal to number of columns in a matrix. That matrix is known as a square matrix. This is a square matrix here of order m by n or n by n, same order. This is known as n by n. We write it as, or define it as n by n. Okay, not n into n, but n by n we say this. So of order m by n or order n by n is a square matrix. A square matrix is defined when a matrix has same number of rows and columns, or in a matrix, if number of rows n is equal to number of columns, that matrix is known as, this is equal to, that matrix is known as square matrix. That known as a square matrix is known as a square matrix. So this is the definition of a square matrix. Okay, so we will talk about what are the square matrices. Now, in case when square matrices are there, this is the first condition, that a matrix, if it is a square matrix. Okay, then next is what is diagonal matrix here. Diagonal matrix. In this case, the fourth type is diagonal matrix. So a square matrix in which the elements other than the principal diagonal elements are zeros. Okay, that is known as diagonal matrix. Okay, so let me talk about question number 4th type. This is known as diagonal matrix. Diagonal matrix. If a square matrix, let me write it small. If a square matrix has ai, or let me take aij equal to 0 for I is not equal to j. Okay, or I is not equal to j. What does it mean? When aij equal to 0 means non-diagonal elements are zeros, while diagonal elements are non-zero, are non-zero or not zero, are non-zeros, or aii, let me write here, aii is not equal to 0. aii is not equal to 0 means same number of elements. What is the principal diagonal, or let me first define what is the principal diagonal. Principal diagonal or leading diagonal okay, or main diagonal is known as, or main diagonal, it is known by number of names, or main diagonal elements are of same number of rows and columns, those elements lying in the principal diagonal. For example, if I take A11 here, A11, A12, A22, A33, etc. are non-zeros. Non-zero means they are non-zero. They have some elements here. A11, A22, A33, etc. are non-zeros. Okay, that matrix is known as diagonal matrix. For example, a square matrix it is. So a square matrix, we have defined it here. If a square matrix has aij equal to 0 or I is not equal to j, that means non-diagonal elements are zeros, while diagonal elements are non-zeros, or aii is not equal to 0, where I is equal to j. So let me write here. Here a is given like this. Suppose this is 2 here. Okay, 2, 0, 0. Let me take a numerical term here. Okay, and symbolically I'll write, in general form, but first let me write here this 0